Let's spend a few minutes talking about this Venn diagram, which shows number of people who like Snow White, Peter Pan, and so on. And the very first thing I need to address is the missing information, which is the total number of people. The total number of people, if you think about it, is the number of people who don't like either movie, plus the number of people who like Snow White only. Okay, so that's 27 more, plus the number of people who like both. That's 8 people in the middle of this Venn diagram. And then the number of people who like Peter Pan only, and that was 20 in group B, but not in group A. Now we're going to take that information and we're going to put this together with some logic notation. Logic notation in here tells us what we're actually looking for, which interactions of groups we want. So let's go over what these mean. The little U symbol means or. Could be C, could be B, could be both, but it has to be at least one of them. The next symbol I want to talk about is the upside down version of that, which is the and symbol. Okay, so you got or, you got and then you have this third symbol over here, which is the not symbol. See that little C exponent? That means the opposite of whatever it's attached to. The actual word for it in math is complement, which doesn't mean saying something nice about someone. In mathematical terms, it means filling in the portion of you that was missing, okay? Which means all the things that were not you, that's what we're talking about. So let's take those ideas and we're going to put those together over here, and I want to count the number of people in each of these categories. So first of all, let's go after C or B. The number of people in C is this outside group right here. Okay, and then I'm going to combine that with the number of people in B. Okay, maybe you're in C, maybe you're in B. I don't really care. I just want to know how many people are in either category, either C or B. Now I'm going to write B as 8 plus 20, but you could say 28 if you want. The point is, it comes out to 49 total people who are either C or B. Because this is a probability, not a counting problem, I'm going to say that as 49 divided by the total number of people, which was 76. And that's how you do this sort of problem. Let's work through a few other examples. So next one is A and B. That's what I'm working on right here. So let's take a look at our graph and highlight which sections we're talking about. A is the circle on the left. B is the circle on the right. A and B means both of them at the same time, which is this really small region in the middle right here. So there's not a whole lot of math involved. You just say there's 8 people. Okay, that's it. But because we want a probability, we say 8 over 76. Okay, final version. Now let's do the number of people who are in, let's see, what is this? Complement of C or A. So let's write down our shaded regions first. And I really like the highlighting technique because this prevents us from double counting something by accident. If I say what's not C, well, C is the outside, right? This whole region on the outside. So not C must be the portion on the inside. The whole portion on the inside. That includes A and B. Okay, there we go. That looks nice. So there's my not C highlighted in. And I want to combine that with anything that might also be an A. Okay, so if I highlight A, that's this circle on the left. Now it doesn't have to satisfy both of these things. It either has to be not C, which is the light green, or A, which got double counted, that's the dark green. So how do we count this up? Well, it's everything that you see, which is, let's see, that's going to be 27 plus 8 plus 20. Notice I'm not counting just the dark green area because this is not an and problem. This is an or. Either one of these is just fine. So let's see, that's going to be, looks like 55. As a probability then, this would be 55 over 76.